Up next, we have a presentation by Muhammad Arslan, Big Data and AI Architect at NVIDIA Technologies AB. He will have a presentation entitled A Journey of Auditlogs from Kafka to ElasticSearch. Mr. Muhammad, the stage is yours. Please.
All right. I'm Muhammad Arslan, and I'm working as a staff software engineer and a big data architect at a company called NVIDIA. So last year, or a couple of years ago, we started building a centralized audit log platform, right? So we had so many microservices that are hanging around in the different environments. So we started looking into, okay, what kind of solution we can build that basically can help us scale at any point. Since audit logs are very, very important, right? And sometimes they are even important than the application data itself, right? So we start building and looking into, different options. So that's the journey that I will going to speak about today. All right, so this is like the quick agenda for today. We're going to have an overview of the platform. We're going to go through like a deep dive on the architecture. We're going to a little bit talk about Kafka and OpenSearch, and the most important part, how we monitor it and how we alert if there is anything goes wrong, right? So security part, very important again, and the most important part is, of course, how we back up the data and how we recover it if there is any disaster recovery happen, right, or any disaster happen, right? So raise your hands if you are using Kafka in production. All right, quite many people. How much load are you running? Are you anyone running on over 1 billion a day on Kafka? All right, cool, there are a few. All right, so you're gonna love this presentation, right? Because that's the scale that we are aim for, and that's the scale that we have built this platform for. All right. So what is audit log, right? So, I mean, I don't want to assume anything. I really want to know what is actually happening in the system, right? So what is changed and who changed it, right? So if most importantly, right? And I want to see what was the state before and what is the state now, right? So I want to compare the state in between. Right, so audit logs are very critical part, as I mentioned, because I mean, losing an audit log is a disaster itself, right? So, and it's a blocker for all other microservice applications as well, right? So for example, if the application has to make any modification, any microservice has to make any modification, right? And the audit log platform is not working. So that can be a big problem, right? Then that can be a downtime, and then that can lead to a problem where you actually have to, where you can't actually do anything, right? So basically, so what we build is basically a platform that has a, two-phase commit, right? So basically, in my microservice application, I say, okay, I want to make this, change, right? And I want to start with one commit to this platform, saying that, okay, I'm going to make this change, and this is a change I'm going to make, right? And then I perform the change, and after that, I say, okay, I have done this change now with the state of commit, completed, right? So, and then if something goes wrong, you can always, have a, failed or unknown state of that one, so that you can track each and every change that you have that has been performed in the environment, right? And you can also track on a who has done it, right? And then you can also track, for example, if I want to have logs for, one person who has performed, changes on 100 different microservices, right? So that's something that I can have as well. So requirements are really, really tough. And the SLOs, were really, really important for this application or this platform, I would say. So 99% of the request has to have less than 100 milliseconds. and 75% of the request has to have less than 30% or 30 milliseconds, right? And we want to, scale pretty easily, right? No downtime. And I mean, we are running all this platform in Amazon. So it's a MSK and, OpenSearch, ElasticSearch, new version. And they have, deployments green and blue. So you don't really have any downtime, basically. We Terraform it. There is no vendor lock-in that we want to have. So basically, there are options on the different, platforms or in the clouds, native cloud applications, that you can use actually to track the logs. But we didn't want to, lock in with one of the vendor, for example, Amazon or Google Cloud, right? And alerts and monitoring, right? So on the basis of that requirements, we have done POC and explored all the different options that are basically available, right? So we went to check on a full cloud native, for example, using all the managed services, Kinesis, and Kinesis Firehose, Elasticsearch, and just build like a couple of custom services on top of that, Java applications basically. And we also checked like managed services and custom loader, SNS, SQS, direct write to ES, and then we found, okay, if we write to direct to ES, then the load we cannot handle. If, for example, if there is like 10,000 requests or 20,000 requests per second are coming in, we cannot handle that load. We need to have something queue in between. That's where we picked Kafka. So the Kafka plus ES was actually the winner at that time. So this is like a simple service architecture, right? So basically what you have is here is, the couple of apps or whatever apps are. They are writing through a Java REST API directly to Kafka. And the Kafka is running, there are two connectors running basically from Kafka that are syncing all these logs to Elasticsearch and as well as to S3 as a backup. If something goes wrong, we have a backup that we can recover from, right? And then, all the read path is directly from the Elasticsearch side. So write API, pretty simple, as I mentioned, endpoint for posting, audit log. It's a two-phase commit. That means each request that you send in, you have to send like a, another request that's basically can complete the state of that one. So for example, the first request you send started, and then the next one, perhaps if you have done the change successfully, that will be completed. Otherwise, it will be failed if there is an exception happened, or it can be unknown for any reason, right? And for making this entry to trackable on the server side on Kafka and Elasticsearch, there is a hash or entry ID. Basically, you need to send in the request so that we can match it on the server side to see that, okay, these two requests were belonging to each other, or these were the requests that were belonging to each other. Yeah, so this is a simple sample request initiator, who's actually performing this operation. So it's like all the auth tokens basically that belongs to the user. And then there is an entry ID. It can be anything, any random string, but we recommend usual ID. And and then we have a entity. So what entity you are going to update on or perform an operation on, right? So it can be goal, it can be campaign, or it can be anything else, right? And then there is a free JSON object context, right? And that can be anything. You can write anything that you want to there. So how we design it, okay, we give the independence to the developer what they actually want to write on, right? So basically they can write two objects, old and the new. So that will going to be the old state of the object and then the new state of the object. And that's where you can track on, okay, what change has been actually performed in this specific operation. And then event, right? If it's a create request, if it's an update request, if it's a delete request, or yeah. And then there is like a log message, optional log message, and there is transaction state from started and completed or failed or whatever. Right. So yeah. So as I mentioned, simple write API that's writing to Kafka topic. Currently, we have a retention for 5 days, and it has Kafka has 10 partitions, right? And I mean, we can scale whenever it's needed, but at this point, it's actually, feeling or like, satisfying the behavior or the SLOs basically. And the messages are sent in an Avro format. They are compressed. And so what happened between Kafka to Elasticsearch or OpenSearch? There's a connector. It's an open source connector from Confluent, right? So you can actually read the data from Kafka topic and put that data to Elasticsearch. And so the important part here, the way how Elasticsearch scales, they actually scales on the basis of indexes, right? So indexes are really important here. So because over time, the indexes, you have some hot data, and then over time, perhaps in a year time, you are not really interested in a year before data, right? So the most important part is what is hot data. So to cover that, what we have done is we have created a monthly indexes, right? So whatever event time that you send in, that will going to be ingested automatically by this connector to that specific index of the month. And that is that I will going to show you in a few minutes, the ingestion pipeline, how we designed it. And this is simple, another connector that's basically read the data from Kafka topic and upload the files in S3. And these files are in Avro format, and these files are used to reprocess the data. For example, if you lose any data, you still have the backup that you can reprocess and replay the data, and then that will end up basically the specific indexes in Elasticsearch. And current retention for this one is 3 months, because Elasticsearch has their own backups as well, right? Okay, I mean, Elasticsearch, I don't need to go into that detail, but I mean, it's a new, OpenSearch is a new version of Elasticsearch. It's an OpenSearch version, and you can easily scale it. It's a managed service from Amazon. You can scale it even like with a single API call. So this is the setup that we have. It's basically 3 master nodes, and then the data nodes. So what master node does is basically can communicate and knows that where the data is actually stored, right? So they have the metadata of all the indexes and the hashes that basically be stored over the different data nodes. So there is no real data actually stored on the master nodes. They are just communicating with the data nodes accordingly, like where the index and the shards are basically hosted. And this is, index of Elasticsearch. Elasticsearch is based on Apache Lucene, and each index can have a multiple shards. Multiple shards can have one shard can have one Lucene index, and one Lucene index can have, multiple segments. So this is how Elasticsearch write optimized it. So basically, whatever you write it creates the multiple segments and the different files, right? Over time, these segments are increasing. Right. So what happens is, with passage of time, when you actually need to read optimize it, then you can combine all these segments together to one big segment, right? And that means then it will going to be, read optimized. In this current structure, it's more write optimized. And each Lucene index is basically can have over 2 billion records. So it's pretty big index anyway. And then this is something that you can specify the policy for OpenSearch lifecycle management or index lifecycle management, right? So the current state of each index is basically a hot. Then you can say, okay, over 3 months, change that index to the warm state, and then that means that the index will become a read-only. You cannot write it to that index. And then you can say, okay, in 2 years, make it cold, then perhaps in 5 years, delete it, right? So this all happens automatically with the index lifecycle management in OpenSearch. So index template, these are the templates that basically you create to actually make more structured way of writing the data, right? So you want to create a template or a schema, what you're actually going to write basically to OpenSearch, right? So you can just call the API and get whatever template you have configured on the OpenSearch at the moment. So this is a complete like a sample thing here. So you can see an index and the pattern, and as well as, you can see, for example, what is ingestion pipeline is that I will gonna show who actually ingest the specific record to the specific index in the next slide, perhaps. Yeah, so the policy is the same thing. It's a hot, warm, cold, and delete, right? Over time, the indexes, automatically be moved to these specific states. And this is a policy template, right? So it's very simple. It's a JSON document. You specify, okay, after a month, change the index to warm state, right? That's something you can do. And you can also specify the size of the index. Let's say if the size is like 20 gigabytes, if the index is already 20 gigabytes, it will gonna roll up the index. It will gonna basically create another index that will gonna be part of that specific, month as well, right? And you can also specify like, other multiple conditions. For example, in 3 months or 6 months, you want to perform another operation on the specific, index. So yeah, so this is very important part. So this is a ingestion pipeline. So what it does is it checks the index prefix name, right? So the index prefix name is okay. All the indexes that basically start from SRE int auditlog.v1, right? And then the rest will gonna be appended with a date, every start date of a month. It's basically take the timestamp field from each record and then take the month of that one and append it to that specific index, right? So for example, if I'm sending a request of mid of the month, this will gonna get the first day of that month and ingest that specific record to that month, right? So in that case, all the indexes, all the records that belongs to that specific month will be ingested to that specific index of that month. So why we needed this one? Because we don't want it to have any duplicates. So for example, if you have a disaster and you need to recover the data, you will have an inconsistency, right? So for example, last month, there was a 2 billion records and you have like, 100,000 less. So you cannot figure out that 100,000 records. You need to perhaps replay like most of the month, right? If you replay it, you might end up with duplicates. In this case, it knows that what event actually belongs to which specific index, and then according to entry ID or like the primary key kind of concept that Elasticsearch has, it will gonna replace that specific object automatically. Yeah. So how do you calculate the storage requirements on Elasticsearch? Right, so let's say if you want to store 30 gigabytes of data, right, with the 2 read replicas, right, so it's a multi-easy. So, and then there is an overhead of 1.45 on top of that. So basically storing the 30 gigabytes of data in Elasticsearch will gonna end up 130 gigabytes of data in total. So that's the storage. And what is 1.45? That's the overhead of all the backups that it does for you. So it keeps the backup for 7 days, for the last 7 days. And then then there is also possibility to actually keep the backups manually as well. At some point, if you want to, migrate to a bigger index or bigger in cluster, basically.
Yes.
And so this also explains like automatic snapshots, 1 week retention, and manual snapshots can be done and transferred to S3 bucket automatically. So for example, from the console of Elasticsearch, you can, run the S3 backup automatically, right? Data can be restored anytime. It can be restored to specific time as well. It can be restored to any, point of time of snapshot as well. So I mean, backup and disaster recovery, these both are equally important. You always need it. You always need to do it. Without this one, you cannot really, make your system running. And most importantly, monitoring part, right? So how do you want to monitor your cluster? So what happens if the cluster is having issues? What happens if Kafka is having issues? What happens if, Elasticsearch is having issues, what happens if your data is not ingesting correctly from Kafka to Elasticsearch, right? So there is a very strict SLOs that you need to follow up, right? So how do we monitor that? So we use Datadog for these ones. So we have a platform that's basically monitor, a dashboard basically monitor all the SLOs, right? So here when we send the request, right, so we log each time of the request, and then we send that metrics to Datadog. And then we have the SLOs, and according to the SLOs, we raise the incidents if the SLOs are increasing in terms of the time, right? And then there is a bunch of other metrics as well that we follow up. And then there's an important part, synthetic test as well. So that's like a ping service. That's basically call every minute and send one request. And then it measures the time from Kafka to Elasticsearch, how much time it took to actually reach that. That's how actually we check all over SLOs, right? So for example, if it's taking over 100 milliseconds, then we report that to Datadog. And then this is the OpenSearch. This is like the standard metrics from OpenSearch. You just need to configure it, and all these metrics goes automatically to Datadog, right? So this is basically giving you the overview of how much space do you have left on the different data nodes if you need to scale up, or what latency requirements do you have at the moment, right? And then we are using MSK at the moment. So MSK has its own monitoring as well, where you can see how much are the producers are taking, Kafka producers are taking, and what is the lag on the specific topics. So all that things you can see, for example, in Datadog. And security, currently, we don't really have a high security requirements for these ones in terms of who's accessing it, because it's a pretty internal system, right? And OpenSearch UI is basically behind the OAuth proxy, and that is basically be connected with our SSO. And then there is no IAM, or we cannot see, for example, who run this query on the UI at the moment, right? But there is a possibility that you can do that. You can configure it with the IAMs and the logins and all that. And yeah, in security, security is very important, right? It has to be there. And so the backups are, as I mentioned, they are taken automatically, automatic every 7 days, and then there is a backups that you can take manually as well at any point of time, and that is basically be uploaded to Amazon S3. And then there is a docs for replaying the data as well. So how does that work? It's basically another application running on another specific Kafka topic, and that Kafka topic is basically writing the same Elasticsearch cluster. So that way, we are not actually breaking the main flow, right? So we actually created a separate flow for that one to replay the data. Yeah, and this is one of the exercises that we have performed when we actually built this one. So we perform in the integration environment, and they call OpenSearch in Amazon, they call it as a domain, right? So we try to update the domain, added more data nodes, and remove the data nodes and perform like a big by sending a big load of data as well. We started playing around with our Java applications, like the connector applications, reduce the replicas, increase the replicas, and see that of course, it affects our latency, but what we wanted is basically to see that we are not losing any data, right? And and another part is basically if, for example, you have to update the policy, if you have to update the data model, if you have to update the ingestion policy, so all that things are very important before you go to the production as well, right? Yeah, so this is what I have. Any questions?
How did you actually solve for the two-phase commit with the upstream stakeholders? Like, how did you educate them that they should be doing two-phase commits?
Yeah, so we have an SDK. That's what we recommend them to use it, right? So that SDK handles all these things automatically.
Yeah.
And then, I mean, education is, of course, very, very important. But on the other hand, if they don't do it, they will not going to read it anyway, right? So it's not, I mean, since this platform is pretty internal, we cannot really, control that. But I mean, we have it in the docs, of course, to make sure that they are following the guidelines before they go there, right?
Cool. Thanks.
Thank you very much. Any more questions? All right. Thank you very much, Muhammad, and
Thank you.
please go to him.